Hello aquarium fans. The main worry for any aquarium enthusiast is to achieve a long-lasting balance that may allow our fish to survive without damage. Considering fish and turtles produce wastes that can break this balance, we must control those wastes. With this purpose, we use cycling, filters, regular cleaning, plants, detritus feeders, and strict control of the amount of feed supplied. Cycling, or the nitrification process, transforms organic matter into components that can be used by plants, nitrates, and removes toxic compounds, ammonium and nitrite. We can verify that cycling has been successful, checking that there is no ammonium and nitrates in the water. All the values are very near to zero. Once ammonium and nitrites reach zero value, we consider cycling has finished, and we won't need to carry out these tests again, unless we suffer a disturbance that breaks the balance, like for example a lengthy power outage or organic pollution. An excess of organic matter can make the water toxic. The filters will be effective if we clean them or change them frequently. If they fill up, waterborne particles will fly past, settling at the bottom, causing a buildup of sludge, which can release methane and sulfur, a toxic problem for the aquarium. Cleaning, especially the removal of uneaten food, feces, and any organic particle that can deteriorate and sink to the bottom. And siphoning the filter box, refugium, sump, or any part of the circuit where solids tend to settle. This will avoid sludge buildup. And some plants. They help us remove the nutrients cycled by nitrification, so they don't accumulate and exceed the tolerances of fish and our other inhabitants. Some detritus feeders that will help to transform the organic matter into more accessible compounds for the nitrifying bacteria. A limited amount of food, just enough to live happily, helps to reduce the amount of organic matter moving around in the water. No, that's enough. An obese turtle is not a healthy pet. Additionally, just supplying the minimum amount of feed needed reduces all our other efforts. We don't have to clean the filters so frequently. We don't have to clean the aquarium so frequently. The community of cycling bacteria are not suffocated by sludge, and we only need a reasonable amount of plants. How much is enough feed? A recommended amount of food for turtles is a dose equal to the size of their heads every 2 days, and change that amount if they eat it all or leave some. Turtles tend to leave food. It floats about, settles at the bottom, or ends up in the filter box. So it's better to feed them more frequently, or give them the pellets one by one and stop when they lose interest. Regarding fish, we must consider that many fish get food off grazing algae and plants, so the feed we give them is mostly a supplement, except in those cases that require a special diet. The most objective way of establishing the amount of feed is as a percentage of body weight, or fish size. Searching the literature, we can estimate the weight of a fish of a given size and form, and which is the weight of all fishes in our aquarium. We should start with a maximum of 10% of the body weight. In this aquarium, I have 4 barbs, 15 gambusia, and 2 guppies. The total weight of these 21 fish is 220 grams. In this case, the percentage, 10%, is 22 grams. That's what we should give the fish. And with that starting point, we can give them more or less according to the behavior of the fish. If the fish leave residues after about 5 minutes, reduce the percentage accordingly. In fact, as fish grow, this percentage of body weight falls according to those studies. To check if these controls are working, there are a few signals we can look out for. Although both nitrates and phosphates are needed for an algal bloom in an aquarium, it is the level of phosphates the limiting factor for a bloom. And this level shall be our main indicator of dangerous conditions, and it forces us to carry out regular tests. If we exceed the amount of recommended phosphates, this means our controls are failing, so we must act on reducing those phosphates. Now we only need the other factors that promote a bloom: lots of light, high temperatures, longer days, and slow water circuit. We have a bomb in the making. A few algae and cyanobacteria on the walls and bottom of our aquarium is not a bad thing. They are useful as food for many aquarium animals, including fish. They help in reducing the nutrient load and produce oxygen. But an excess is harmful. Snails and fish can't cope. Aesthetically, algae and cyanobacteria can make the water go green and produce a disgusting smell. On the front glass, they won't let you see anything, and on the other surfaces, they'll hide the fish. Functionally, they will handicap the development and photosynthesis of the other plants by obstructing the light and colonizing the macrophytes till they suffocate them. When they form a hard sward on the bottom and walls of aquariums, they darken the environment and make maintenance much harder. If the bloom is extensive, or if the algae die off due to depleting nutrients, their decomposing bodies can deplete the oxygen in the water, causing the death of fish. Some cyanobacteria and algae are toxic, both for humans and animals, so they have been the focus of most studies about cyanobacteria and algae blooms. So, if we don't check phosphates regularly to ensure they don't exceed the limit, when we start seeing algae all over, we must assume it's a signal that our system is broken. In this case, the first thing we have to do is test the phosphates and ensure they are below the recommended values. Which are these recommended values? It's difficult to find consensus in the literature regarding the recommended phosphate limits in an aquarium or pond, in part because there are many factors involved in a bloom, including high temperatures, strong light, and too many phosphates. Additionally, it varies with the type of aquarium. After reading many documents, I believe we can use the following limits to avoid the risk of a bloom, although we must also limit the amount of light. A seawater aquarium with coral, 0.02 to 0.07 milligrams per liter. A seawater aquarium without coral, less than 0.10 milligrams per liter. A freshwater aquarium with plants, between 0.5 and 1.0 milligrams per liter. An aquaponic system, less than 2.0 milligrams per liter. And a hydroponic system, over 20 milligrams per liter. If we exceed the recommended levels, the next step is to do a water change, depending on the level of excess we have and the sensitivity of our creatures. It is preferable to do a series of 30 to 50% water changes along many days instead of doing one big water change all of a sudden. Considering a water change reduces all nutrients available, we should also remove the most algae possible, because if they die off massively, we might worsen the crisis we have. Removing algae with manual tools is a slow process, and it makes the water murky. For this reason, we must remove the algae before a water change. It's also a good idea to transfer the most sensitive fish to another aquarium. There are quite a variety of tools for removing algae: siphons, brushes, sponges, abrasive cloths, and different types of spatulas, including razor blades and credit cards. But they all just dislodge the algae. They don't remove them. For that reason, it's a good idea to dislodge the algae holding a siphon or pump filter next to the tool, so the water changes are more efficient. We must also use a siphon to remove all the organic matter that isn't trapped by the filters while we're changing the water. Once we finish the water change, we must wait 24 hours to carry out a new phosphate test, so we can assess if we need another 30 to 50% water change. And we repeat this process many times till we reach the recommended levels of phosphates. And at the same time, we can remove most of the algae stuck on the walls, the bottom, the plants, the glass, and other objects. We will never get rid of all the algae. And as I said before, algae can be very useful as long as they don't become a nuisance. Finish the emergency, we go through our management protocol and update whatever is needed. Less food, feed less frequently, clean more frequently, more frequent water changes, more macrophytes, and more algae feeders. In this way, we will achieve a harmonious environment with microalgae, macrophytes, fish, and others, without the risk of an explosion of algae unbalancing the whole aquarium or pond. Well friends, that's it. I hope you liked this video, and if you did, please remember to give it a thumbs up, share, subscribe, and thanks for watching. Bye bye.